I'd like to introduce myself. My name is Tom Leahy. I'm the head of A&D for SiFive. This one is going to be a little bit different than most of the things. I'm not going to talk about auto vectorization, out-of-order execution units. It's a little bit different, so it's got a little bit of a tact on A&D and the government investment that's going on right now. I'm planning on hitting on the high level of some of the A&D challenges. I don't know if a lot of you have been involved in the aerospace and defense side, but really just want to bring you down to that level as to what challenges they're up against, and then some investments that are being made at the national level, as well as then really just jumping into the U.S.-based microelectronics activity from a funding perspective. And the bigger thing is, how can RISC-V help? I think you've heard everybody start off today. It's really a community, and it takes a village to go off and do these things. But we've really got an exceptional opportunity right now within the A&D arena with all of the onshore funding and all the activities across the globe today. So, just at a high level, right now, most people probably in this audience, if you've been in the semiconductor arena, have probably stayed away from the aerospace and defense side of the business. And in that case, commercial sector spins things a lot faster. But right now, there's a huge push in the A&D industry to really decrease those schedules and start getting on commercial timelines. That's a tough task, but right now that is what they're looking to do. They're trying to provide an asymmetrical advantage, for all the different programs that are being done. The amount of activity that's going on in the compute space is just out of this world at this point in time, with state-of-the-art technology being needed, not being on the old nodes, not using everything that was a little archaic, if you will, in comparison to what's been done from years past. Extended longevity, that still sits in there, looking at 15 years all the way up to 20, 25 years for a lot of different platforms before they even do upgrades. So there's always that issue with regards to the flexibility of supply, et cetera. Scalability, upgradability. That's something that they're really struggling with right now and spending a lot of time to try and create an advantage compared to what they've been doing in the past. They're also putting together a big cross-functional team, so you'll get a little bit more details of what's going on with the CHIPS Act and the Commons, Microelectronics Commons that I'll give you feedback on. But right now, the Department of Energy, the Department of Commerce, and the Department of Defense are trying to get a cross-functional team going so that they can leverage as much as possible. With that, that's something that's incumbent upon us to make sure that we're bringing forth that asymmetrical advantage so they can start using state-of-the-art technology and bringing things forward. They get struggling with SWaP-C all the time. So SWaP-C is size, weight, and power. Cost is on there as well. They are starting to really start looking at the overall program execution and how much cost, overrides, et cetera. There's a lot more scrutiny to the programs, and they're up against that, so that's one of the big things. There's continuous adversarial threats, new opportunities where people are using commercial, if you look over at the Ukraine right now, they're using a lot of commercial things and just really patching things together, but that's another threat that they have to take advantage of and serve almost immediately. And overall, the ecosystem, they're looking to have a partnership between the public and the private entities. So that's something that's really getting pushed as much as possible, and I'll get into a little bit more of the details there, moving forward. Getting into some of the lower level requirements, what are they? Is, lower PPA, the power performance area. I don't have to tell anybody in this room about that, but really to address the SWaP-C. Even if you look at some of the large EW electronic warfare type applications, they only have so much power on those planes, and they've got to be able to treat that in. They have more feature creep, more adversarial reaction that they have to have. They are just up against it. So that lower PPA really has something. If you have the power density to be able to talk and assist in that, the performance that can bring some of the new functionality that need to bring forward, that is something that they're constantly looking at. They haven't gone down the path of where they're fundamentally looking at programs and they don't schedule some of these tech insertions, which they need to do because of things going away. So we really need to bring some of that forward. The ecosystem development growth, the open standard side of things, that's again, they just see from an overall community, they see a lot of opportunity with RISC-V moving forward. They've got the secure AI and edge processing that's being done. You've heard about that a little bit from some of the announcements that have been made today. But in general, in the aerospace and defense groups, they need that more and more, and they're looking to try and bring that forward, trying to have more compute. If I was just out at the ME Commons last week, and every other word, I swear to God, was compute. They just keep pushing the technology and trying to drive as much as possible in integrating that edge and ML processing. Radiation hardness. A lot of space-grade opportunities are there. So you can look at, there's a lot of activity going on in the 5G, 6G arena, and future G, as they call it. They are also looking at, again, having things that go all the way from rad-hard to a commercial viability from an opportunity perspective when they start bringing things to bear. And that's something that we have to think of as a group to bring that forward to make sure that we're considering that. Trusted IP ecosystems. Right now, as it stands, the fabs are really the only trusted entities, from that whole process flow. They've got a lot of stuff that's going on, that's being funded from DARPA for like RAMP-C, where they try and take that trusted flow through the whole side, but they don't have an IP ecosystem, including our IP, that is trusted to where it meets that level. They're trying to define that as it stands right now. There's a lot of opportunities in that space, moving forward. And one of the biggest things that they're looking to do is, the innovation side. If you go and see any of the presentations that are being provided by the Department of Commerce or the DOD right now, they talk about the valley of death. It's very simple to create, I won't say simple, simple's the wrong word. It's much easier to create a one-off that's done out in the lab, but to bring that lab to fab, that's the biggest thing that you hear. It's all about lab to fab. How can you take that technology and bring that so it's a manufacturable product that's worthwhile? So that's the valley of death that's being talked to. They want to create and grow the chiplet ecosystem. You see a lot of presentations that were being done today talking about a chiplet ecosystem. A lot of the packaging that is being needed out there. If you look right now, everything's primarily done over in Asia. And with that, there's a lot of packaging infrastructure that's coming out this way where they want to have a lot of onshoring. And with that, we want to take advantage of that. We want engagements in the CHIPS Act and the NSTCs. I'll get into a little bit more of that in the Microelectronics Commons as well. But really just an awareness of the future needs. So they're telling us what they need, and we need to make sure that we're there to listen to it as a community, bring that forward, create the ecosystem that's needed. So if you look at it from the semiconductor investments right now, this is seen as a national security situation. That was all brought about by the lack of supply. So that is truly a national security issue. We've got the CHIPS Act funding that's $54 billion, excuse me. European CHIPS Act. We've also got a CHIPS Alliance that's between USA, Japan, South Korea, and Taiwan. There's many others. Everyone's looking at things now as to how we can be self-sufficient, how we can create our own ecosystem, but yet still work with the allies, if you will. So it's really a time like no other for us to be able to go off and penetrate and be the de facto standard processor of choice. All these recent fab announcements, I'm not going to go through all those, but they just keep coming out on a daily basis. They know that the CHIPS Act was coming. They're looking for funding opportunities. There's also a lot of tax credit capabilities. I'll talk to that as well. But this is just all from a fab side. You've also got the same type of thing going on in the U.S. packaging activities. We're looking at bringing on 4 to 5x the capacity in a fab, but yet we can't even come close to handling that from a packaging perspective. So there's a lot of things that are going on right now. Intel's made a big push, Skywater as well, Amcor and Northrop Grumman. A lot of folks are just saying, how can we solution our own problems, look at different packaging technologies, and again, try and get to the state of the art. So the CHIPS Act and the overall budgeting side. You've all heard of the CHIPS and Sciences Act that was signed off finally in August of this year. That sums up to about $248 billion. I'll get into a little more of the detail there. So know this is small and it's not meant to be a reading exercise for you, but in red is where we can fit in from a process or IP perspective, and really drive things in the semiconductor world. You've got the $39 billion that's going to be attributed to all the fabs, the packaging, et cetera. But there's $11 billion that's for the research and development that we can have an impact on to bring things forward, to make a differentiation to the, I can't use the word warfighter, but I was going to slip out of my mouth. But anyways, with that being said, we've got another $2 billion from the DOD. Again, we'll get into a little bit more of the details, but $170 billion are being spent. This is above and beyond the normal budget. So this is a time like no other from a semiconductor standpoint. It's really a once-in-a-career perspective. So the CHIPS Act, again, $39 billion. And then if you look at the $11 billion, they're going to be creating what they call the NSTCs. So these are communities, or you can look at them as somewhat as hubs, where these folks are going to get together, look at certain concentrations of technology, bring that forward, and dole out that $11 billion. So this is all for things for people working together, creating co-proposals for a lot of different activities. That has yet to be done. Right now they're saying it's February, probably March, where they are going to come out and announce the NSTCs. They had about 280 different applicants associated with that. Then they also have a packaging, advanced packaging that goes along with that. So that really gets tied in together. And then lastly was the DOD Commons. The DOD Commons is a little bit different in the sense that it's a $2 billion budget, but it's $400 million over 5 years. Normally they step things out, so they're really up against it to spend $400 million each and every year. You have to have that deliverable. So it's a little bit of a different thing that they're dealing with. They've got Navy Crane and your company NXXTL, which is facilitating all of the procurement, proposals, et cetera, and really managing that side of things. But the key areas of interest, if you look at secure edge computing, 5G, 6G, artificial intelligence, they also have electronic warfare, commercial leap-ahead technologies. With that, this is all things that RISC-V can address very well. They are trying to figure out how they can best reach out to the community and figure out how can we bring that technology, create that asymmetrical advantage and bring that forward, not only to themselves to be able to solve things, but bring it forward to the commercial, to have things that are commercially viable as well. That's something that's key to them. They do not want one-offs. They've been doing that for years, and that is not the way that they're going to be able to progress moving forward into the future. Trusted A&M, this is fundamentally just all of the trust that I was talking about. But this is another almost $1 billion worth of spend that they are looking to put forward from a DOD perspective, and really just reduce those barriers. Have the onshore type fabs, have that applicable, have that available, have the ecosystems that are in place, go down the trusted path. This is really, how do we create an infrastructure? Again, this is going on all over the world, within Europe, et cetera. I'm talking about the US one, to say, how do we reduce those barriers? How do we bring things from the world of academia or one-off technology and bring that into something that does have the capabilities of being fabricated and to be into production? So at a high level, how can we help? We've really got to engage the government agencies. It's not I'll say a simple model by any stretch of the imagination. If you start talking with, the Department of Congress, they aren't used to spending money in the microelectronics space, but they've been targeted to go spend this $11 billion because it's considered national security from a supply perspective. But it's got a huge thing to go on to solve. The defense industrial base and all of the allies, we need to engage all of that. When I say defense industrial base, that's the likes of Northrop Grumman, Raytheon, Lockheed Martin. Drive and understand where the opportunities are to be able to offer and stand up and say, okay, we can bring something further that has more technology associated with it. But we need to know what your engagement model is, as well as all of the feature set that's needed for that. There's a lot of consortiums that are going on right now, as I was stating, for some that are vying for support of that NSTC that will help divvy out those the $11 billion. IBM's got one. It's out of, they're working very closely with the state of New York. So there's a lot of different political affiliations that, we've got to go down and tear that down to understand how do we best help out. MITRE Ingenuity is another one. They're a nonprofit organization. I think they've got over 80 companies that are in their consortium, and they're going to be looking at things, again, to meet the requirements that are being put forth from the Department of Congress and, all of the subject matter experts, surrounding that. We're going to expand the ecosystem to the next level. Looking at things only from a commercial viewpoint doesn't, solve the problem. Here in the A&D space, most people don't realize they are on the leading edge of technology. They may be, a little laggard as far as deployment, but they're always on the leading edge. And if we can take advantage of that and really say, okay, how can we leverage the opportunity that sits in front of us today and bring forward better technology that can be utilized to solve their problems, and then bring that and have commercial viability. All these proposals that are being put forward, that's going to be one of the major criteria that they're looking for within those proposals, is something that has commercial viability, something that is solving a problem today, or one that they've got to solve within the next couple to 4 years, if you will. Jointly we need to continue to drive and make RISC-V the de facto process standard. It's amazing how engaging folks are right now, and that goes across the agencies, the defense industrial base. Everyone is looking for a solution. They're looking for help. In a lot of cases, they need that help. They aren't necessarily always the semiconductor savvy, if you will. You've got some folks that have been in there and now they're the subject matter experts, and they've been doing it for 6 months and they don't even have a technical background. We need to step up and help in this situation. As it's stating here, is it really need collaboration across academia, the industry, all the allied countries. We need to step up and solve this problem and help assist to solve this problem. So really, what I'd say is a call to action is we need to also support investments that, into the A&D side of things, and really look at it from a national or worldwide semiconductor arena, and just continue to drive RISC-V across all of the different facets of the organizations. There's a lot of stuff that goes on, again, that just has direct correlation into the commercial world, and you're going to be able to leverage that as much as possible. And the one thing, if you have dealt with aerospace and defense companies, they're friendlies for the most part. If you don't deliver, that's a totally different story. But in general, they are willing to help, willing to educate, willing to really have a partnership that goes. Trust goes a long way within the A&D space, and that's something that we as SiFive are definitely open to engage on strategic relationships and partnerships and collaboration, looking at the fab and manufacturing level, talking to all of the onshore fabs as well as the ones that are supporting our allies, making sure that we have the proper infrastructure in place to be able to support all of those. Software tool level as well. There's different things that are needed relative to ecosystem tools, EDA tools, our own compilers, making sure that we understand how our devices are being used, as well as everyone else, to understand that use model. And in the case of aerospace and defense, it's usually a little bit more complex than the normal commercial model, because they've got to take into account so many different items. And with that being said, just looking at talking with the defense industrial base, our industrial allies, and lastly on the academic level, we want to make sure that we are engaging, embracing, that whole community, because a lot of great effort is being done. And if we can take and look at what we could partner with and bring some of those proposals forward, that's really what we're looking to do. So I think that was really my summary. And with that, I could open it up to questions.
Okay. A lot to think about there. We have time for one question. Somebody got one? Got a great one that you're mulling through here? Come on. There's one here. Somebody's got one. No? Oh, we do. Hey, look at that. See, if I wait long enough, somebody will.
What do you perceive as the biggest headwinds for this market right now? What are the biggest challenges that need to be overcome to really make this become effective?
I think, from an A&D community perspective, a lot of people are aware. There's still a little bit of the evangelistic stage, but I think, it's really creating some of these partnerships that I was talking about. Willing to work on proposals together jointly, bring those forward to have some of this stuff subsidized, to be quite honest. And it gets the ability to move that forward. But I think that's one of the biggest things that the A&D community has right now is, okay, we've got things that we've used in the past. That is used again and again and again. I worked at Raytheon for years, and they're going to continue using the Patriot missile for the next 40 years. They need to have upgrades, but in the case where I'm seeing really the issues is trying to make sure that people do step up, are willing to partner, and across the whole RISC-V community that we do that.
Great. Let's give Tom a round of applause and thank him for his time. Thanks. Nice time.